Let's proceed with the last 4 problems of the homework. We're given a polynomial with the following formula. It is of 4th degree. And we have to state the degree and the leading coefficient. Now, I already mentioned that it is of 4th degree, but how do we get that? Assuming we have ordered the terms into powers of x with their coefficients, of course. As it is here, we have x to the 4th, then squared. We are liking x cubed, but that's fine. X and no x at all. Then the degree is the highest exponent of x. If we have it in order, the leftmost exponent of x. So degree in our case is 4. Now, leading coefficient is the coefficient in front of the term that we took the degree from. So we took the degree from x to the 4th. So the leading coefficient is equal with minus 35.9. Now, those two together, the leading coefficient along with the term that we got the degree from, it's called leading term, and I might refer to that later. We have to describe now the behavior for very large x. That implies going to minus infinity or going to plus infinity. Either case is very large. We don't just mean large in the sense of positive. It is a degree or degree 4 polynomial, which is even. So the polynomial at the end will be looking something like this. Maybe it has some fluctuation there, but as we zoom out, we won't care about the fluctuation. We only care about those parts. Now that is for A, positive, for the leading coefficient being positive, and a parabola or any degree even polynomial with leading coefficient negative, it'll be looking like this. Here we do have a leading coefficient that is negative, and we do have an even degree. So the behavior for very large x, one case is x goes to infinity, then we have that the polynomial goes to negative infinity. As we see, it goes down. Now for x goes to negative infinity, we also have that the polynomial goes down. Another way to remember it is that for even degrees, it does the same thing regardless of what infinity we have, while in odd degrees, it flips. As long as you know one, you know the other in either case. In the next one, we are given a polynomial that is now factored. It's not as before x 4th, x cubed, x squared, etc., etc. We still have to do the same process, state the degree, and find the leading coefficient. For this one, in order to get the term with the highest exponent of x, since each parenthesis has at least one term of x, I need to multiply those out. So I only will multiply out the products that from each parenthesis I include the highest term of x. So it'll be x times x times x times minus x. So the leading term will be minus x to the 4th. Now from this, I will find the degree and the leading coefficient. The degree, as we see, is equal with 4. And the leading coefficient, since we have a minus, it's a minus 1. Now, in these parentheses, we only had linear terms, that is terms with just x. If one of the parentheses was x plus x squared, I would have picked to multiply with the x squared. I multiply out each term, one term from each parenthesis, and the term that I pick is the term with the highest power of x. I multiply each leading term in each parenthesis. Now, to describe the behavior for very large x, again, it is only based on the above facts, the degree and the leading coefficient. We don't need to multiply everything out in order to find the behavior at very large x. We have negative leading coefficient and even degree. So it will be looking like this. And hence, as before, for x goes to positive or negative infinity, the polynomial will be going to negative infinity.